Alright, so for explain 3, modeling with general trigonometric functions, we're going to be going over some word problems in explain 3. You noticing a pattern? We always tend to do that. We'll show you how to do stuff with math, and there's word problems. Alright, so letter A is going over paddle wheels, so in case you've ever seen, these are really awesome. I've never actually gone on one of these paddle boats before, but they look pretty cool. Turn of the century, this is how people got across on like the Mississippi River and stuff, so great history. But now they're just really fun to be on. But anyways, the motion of a point on the outer edge of a riverboat's paddle, because those little paddles kind of propel it through the water, is modeled by a sine function. 8 sine pi over 2 times t minus 1 plus 6, where h is the height measured from the water line, and t is time in seconds. They want us to identify a couple of things. They want us to identify period, midline, amplitude, and maximum and minimum values of the graph. For one of the cycles starting at t equals 0, find all points where the graph intersects its midline and the coordinates for any local minimum or maximum values. And then, of course, interpret that. So we could just graph this using our Desmos calculator, but we also have to interpret what that means in terms of the problem. Okay? So first things first, let's go ahead and graph this out. So let's identify our A value, our 1 over B value, our H value, and our K value. So since 1 over B is actually pi over 2, we're going to solve for B, and we're going to find our period. So let's do that. 1 over B equals pi over 2. Let's go ahead and cross multiply. What would 2 times 1 be? 2. What would pi times B be? Pi b. What's the opposite of multiplying, by the way? Dividing, right? So we're going to divide both sides by pi. And I'm left with b equals 2 over pi. Now, why do we have to figure this out? Because we have to figure out our period for our function. So this would be 2 pi times 2 over pi. So let's go ahead and solve this out. What would be 2 pi times 2? 4 pi. 1 times pi? Pi. Let's see if we can simplify this out even further. So what would 4 pi divided by pi be? Well, that cancels out, and we're left with what? 4. So our period goes on for about 4 seconds. Okay. Our K value, as we can see here, is 6. Our amplitude is about 8. And we'll find our maximum value by adding 6, which was our K, plus 8, and 6 minus 8. So it's going to go as high as 14 and as low as -2. All right. So it's going to take about 4 seconds, just so you know. And it's going to go high as about 14 and as low as -2. So that I can have a few points to kind of graph this out now that I have some information. Let's go ahead and do that. And then what we're going to do next is fill in our sentence starter. So let's do that. Alright, so as you can see here, I opened up my Desmos calculator. I'm going to start graphing, just like it shows here. It's going to load. We're going to type in this equation. So y instead of h of t equals, I'm going to pull up my keyboard, 8 sine, which I can just type in sine, by the way, instead of using the function key, though it's right there, either way. We'll write in our value of pi over 2, so that's pi divided by, oh, I didn't want to do that, pi, I'm going to highlight pi, so it's only dividing that pi by 2. Click over to the right. Continue to write in parentheses x instead of t minus 1. Ooh, see how it forms it as we're talking about it right now. Plus 6. Wow. That's a lot. So as you can see here, I'm going to kind of scroll over so you can see our graph that's on our page. What we're going to try to do is graph some of these points that we see here on our screen here onto this. Okay, so how are we going to do that? Let's identify some points that we see here. So there's 0, -2. There's 214. Notice how it's halfway between. I don't really want the decimal values, though it looks like they won't go away. Oh, cool. So here you'll notice it starts at 0, -2, goes all the way up to 14, and back down. Okay, and that happens within 4 seconds, and then it just goes on repeat. So we're going to record this on our paper right now. So let's do that. So that would be 0, 2, 214, and then again at 4, -2. So that is our graph. I'm going to try my best to kind of sketch it as best as possible. And now we're going to interpret what this graph means, okay? So just in case you were wondering, the wheel, before we go into the sentence starter, it's going to continually start high above the water and then go below the water. So here it might be 14 feet above the water, which is 0, and then it'll go 2 feet below, right? And this happens every 0 or I should say 0, 2, right? And every 2 seconds, right? It goes back up. So first things first, let's fill this in. So this happens at 2 seconds, 14 feet above the water, -2 feet below the water, and that happens at 0. So just so you know, a visual. Alright, let's go ahead and go into filling out our sentence starter now. So here it says the point blank blank means the outer edge of the blade is blank above or below the water surface at t equals something, right? So let's say, for example, that, as you can see here in the picture, so 0, since we're starting here, 0, -2, means that the outer edge of the blade is about 2 feet. Now if it's negative, will we put above or below? Below, right? The water surface at t equals 0. 1 second later, oh, here's a point. 1 second later, according to our graph, it's at 1,6. So 1 second later, it's at 1,6 or 6 feet. Now since it's 6 and it's positive, will it be above or below? Above, right? And then it says at the next point, which is 214, it'll reach a maximum height of about 14 feet and is back at a height or a center back down here. Starts making its way back after that at about 3,6. 3,6. So, and then it returns back down below the water to its lowest point at 4, -2. All right, and its lowest point is, again, if it's 2 feet negative, so there's no such thing as negative numbers, but is it above or below the water? Below. And this happens at 4 seconds. So notice that there our x value, just so you know, is time in seconds, whereas our y value is our feet, well, distance below the water or above the water in feet. All right, let's move on to part B. So here let's talk about an amusement park, the motion of a gondola car on a Ferris wheel. And I believe on your packet they'll probably have a picture of that, or maybe not, but you should know what a Ferris wheel looks like. You know, it's one of those circle things, you go on it, it goes high. You can also Google it if you've never seen a Ferris wheel before in your life. But essentially we can model the motion of a gondola using a sine function, where h is height in feet. So again, if we do that, our y value is going to be the height of our gondola, whereas t, or x value, is going to be time in minutes, just like on the last one. Time, distance, time, height. It says identify the period, the midline, the amplitude, the max, the minimum, and then of course find all these points, including the graph's intersects the midline, and then interpret what this means. Alright, so first things first, let's identify our A value, our B value, our H value, and our K value. Alright, so I think the most difficult one to kind of plug in will probably be our B value, because you'll notice that 1 over B equals 2 pi over 7. So I'm going to take some time to kind of solve this out, because that's a little bit more involved than just solving out the ones we've done before. That's a B, by the way. Let's cross multiply. What's 7 times 1? And then 2 pi times b is just 2 pi times b. What's the opposite about multiplying? Dividing, right? Now I know this does not look pretty. I get it. But b is going to be equal to 7 divided by 2 pi. So, we found out our b value. Yay. So cool. The next thing we're going to do, well, I'm going to try and make that look like a pi. That's as good as it's going to get, guys. You know it's 2 pi. Alright, let's go ahead and figure out what our period will be. So remember, that's going to be 2 pi times b. 2 pi times our b value, which was 7 over 2 pi. So we can figure out our period, right? So, let's go ahead and multiply across. So 2 pi times 7 would be 14 pi. And 1 times 2 pi? 2 pi. So let's simplify this out. 2 goes into 14 how many times? 7. And what happens to the pi's? Cancel out, right? So that means our period's going to be about 7 seconds. So it's going to go up and back down every 7 seconds or so. Okay. Our K value, well, that one's easy. It's about 80. So that means our midline's going to be at about 80, which is nice. The next thing is our A value that we're going to identify, which was already identified. Our A value is about 70. Yay. Cool. Alright. So we're going to find our max value, which is going to be our K value of 80 plus that 70. And our minimum value is going to be that 80 minus that 70. So let's go ahead and work that out. 80 plus 70, and 80 take away 70. That means it's going to go as high as 150 and as low as 10, because we're not going below the land or the water this time. We're going to be above, but it's going to be either a low point of 10 feet or a high point of 150 feet. Alright, not too bad. Could be worse. Alright, the next thing we're going to do is, I know it tells us to kind of find all these values, but honestly, if we have our decimals calculator, let's go ahead and fill in what we can, just so that we can work this out and then actually find our 1 and 2 and 3 points. Okay, so on our decimals calculator, we're going to go ahead and type in this equation here and kind of sketch those points on our graph here. Okay, so let's go ahead and do that. Alright, now that we have our decimals calculator up, let's go ahead and type in y equals 70. Sine, now you can write it or you can use the function key and find sine. We're going to write in 2 pi. Now since I only want to make that a fraction, I'm going to highlight 2 pi and write divided by 7. I'm going to put parentheses. Instead of t, I'm going to write x minus 1.75, close the parentheses, plus 80. Wow, that was a lot. So let's go ahead and minimize and see what that graph looks like, because you notice it is going to have a value of 10 as low, because we did find that here. Alright, and if I kind of bring my graph a little bit of maneuvering, I was able to get this graph. So from about 0, 10, and up. And another way we can get some more points that are more accurate than the actual graph itself is we could add a table. So, alright, so what we can do here is we can make a table. We got this by writing plus symbol table. We're going to go ahead and write in X for our one column. Instead of writing Y, I'm going to erase that, and I'm going to type in this instead. And I'm going to go ahead and put in some values. As you can see, it's giving us kind of a symbol. It's like empty list are not allowed. So let's fill in some lists. Let's do 0, 1, 2, 3, 4, 5, 6, 7. Now I'm going to kind of amend some of these. So I know I do have a point here at about 3.5. So I'm going to kind of, instead of writing 3, I'll put 3.5. So I do have a whole number there, there, and there. Well, what's halfway between 3.5 and 1, or 3.5 and 0? I'm going to guess and say maybe 1.75. Ooh, yeah, 1.75. So if I add 1.75 plus 3.5, that would be maybe 5.25. Oh, that's kind of cool. So I'm going to kind of erase the decimal ones. And I know it's going to give me undefined because I don't put anything there. But essentially, I have not 1, 2, 3, 4, and 5 points that I could actually record onto our piece of paper. So let's go ahead and do that right now. So that would be, let's go ahead and record some of those values here onto our graph. So let's go ahead and plot those points from the last screen. So that was 0 point. That would be about 1, 2, 3.5, which would go up to about 150. Okay. Our other 2 points were about 1.75 to 80. About 5.25, 80. And then about 7, 10. So it goes up and back down. And our points were at about 1.75, 80. We also had 5.25, 10, or 80, I should say, because those were our points. And we also had on our graph a couple other values, like 7, 10, and a maximum value of 150. Alright, so I think this ends part B. Let's go ahead and, just like it says here, stop and do the problems in your packet, and we'll come back to go over your homework in just a moment.